Here are some more examples on solving exponential equations using logs, and this is when we don't have a common base to use, and we're going to round all our answers to the nearest hundredth. And as a reminder, it's best to not prematurely round and wait to the very end to round. We have 8 times 2 raised to the x plus 3 power equals 48. The first thing we would want to do is handle the coefficient of 8. 8 is multiplied by this power of 2, so we're going to divide by 8. We're going to use inverse operations to solve this equation. After dividing over here by 8, we would be left with 2 to the x plus 3 power, which is equal to 48 over 8, which is 6. And we can see how we could utilize the idea of taking the log of each side now. Now that we have this power of 2 isolated, we could take the log of each side. So we're going to take the common log of 2 to the x plus 3 power, and we're also going to take the log of 6. And now that we have a logarithm over here, we could utilize the rules of logarithms. This power, that exponent, we're going to use the power rule. That exponent is going to drop down in front, making this x plus 3 is going to be the coefficient in front of the log of 2. I'm going to use parentheses around that power not to be confused. Once again, I utilized just now the power rule of logs. So I have x plus 3 times the log of 2, and this is going to be equal to the log of 6. And I want to isolate x plus 3 in order to then isolate x. In order to do this, I'm going to divide both sides by the log of 2. X plus 3 is now alone over here, and this is going to be equal to the log of 6 divided by the log of 2, which we're going to evaluate on our calculator. We're going to take these are all common logs, the common log of 6, and this is divided by the common log of 2, which is equal to 2.584962501. 2.5. I'm going to write down that whole string of digits because I don't want to round to 2 prematurely. And now to get x alone, I have to take away 3 from both sides. I'm going to leave this entire string of digits on here, subtract 3, and I'm not rounding until the very end. And x is going to be equal to negative 0. Now we can round because we're at the end of the, now we know what x equals, so we can round now. Nearest hundredth, the 1 is in the hundredth spot, the 5 next to it's going to round it up to be a 2, so this is going to be negative 0.42. That's the value of x. One last exercise that I want to look at is number 4. We have e to the, so no, that was a common log. Now you have a natural log on your hands that we're going to be using, and that's because we have a base of e. E is going to be raised to the 4x power, and this is equal to 12. So our power is isolated, so the first thing that we could do is we could hit both sides of this with a log. And the log that we're going to use is the natural log. So we're going to use the ln button since our base is e. We're going to take the natural log of e to the 4x, and this is going to be equal to the natural log of 2. We could utilize the powers, the properties and the powers and the rules of logs. The power rule says that 4x can come down in front of the natural log of e. That becomes the coefficient. It's multiplied by the natural log of e, and we know that the other side is equal to the natural log of 12. My apologies, I mentioned 2 earlier. That one sort of got disappeared a little bit, but it's there. The natural log of 12 this should be. I want to isolate 4x. I'm going to divide both sides by the natural log of e. 4x is going to be equal to the natural log of 12 divided by the natural log of e. We're going to do this on the calculator using the natural log button, ln, natural log of 12 divided by the natural log of e, and e can be found using the second division obelus. And this is equal to 2.48. We're going to write down this whole string of digits and leave it in our calculator. We don't want to round until the end. Now we know that 4x is equal to this. We're going to have to divide both sides by 4. Take the decimal that you just got, divide by 4. And this is equal to 0.62. The 1's going to leave that at 2. Again, we round at the very end to the nearest hundredth, 0.62.